Hi everybody, and once again welcome to Pankaj's Echelon Tutorials. And this is a video which is a continuation of the previous video in which I had started with a topic in chemistry subject, and the name of that topic was uh, stoichiometry. Okay, that was the first video, and you may recollect that in that video, I had put a lot of efforts and energy in making you understand the basic concepts, right? And those concepts were basically on a mole concept, then what is AR, what is MR, and all that stuff. Okay, and ultimately I ended up that first video, that session, with this thing that you can see on the screen, this three formulas. Okay, one, two, three, and four formulas, in fact. Okay, so these are the four formulas, and of course, this Avogadro's number, which is equal to 6.02 into 10 raised to 23. This is a very important number. Now, these are the three formulas that four formulas that we have to now, properly understand, and you should know how to use these formulas. Okay, so today we are going to start solving these numerical problems based on stoichiometry, and we'll be starting from the easier ones and we'll be moving ahead towards the difficult ones. Okay, so let me first make you familiar with these formulas. Okay, the formula number one you can see here. This is n is equal to small m, in bracket it is grams, g for grams, divided by ar. So this is a formula which is connecting your n, that is the number of moles, m is the mass in grams of the atoms, and this ar is nothing but the relative atomic mass of that element. This formula you have to use precisely when you are dealing with an atom, okay, or you are dealing with an element. Second formula is similar to the first one. N is equal to m in grams upon mr. Now your mr is nothing but your relative molecular mass. Now this formula you have to use when you are dealing with molecules, okay, not the atoms and elements. Okay, so mr is the relative molecular mass, and n is the number of moles, and m here is also the mass in grams. Okay, the third formula you have to use precisely when you are dealing with gaseous substances, okay, like carbon dioxide, nitrogen, hydrogen, etc. Okay, so this formula says that n is equal to v in liters upon 24, right, where n is the number of moles again, and v is the liters, and v is the volume in liters. Okay, now here I mentioned over here 1 liter and 1 decimeter cube is one and the same, right? uh, this formula, right? 1 liter and 1 decimeter cube is one and the same. Now, uh, 1 second. Yep. So this is having the same meaning, 1 decimeter cube and 1 liter, right? Okay, fine. Now let us move on to 1 second. I'm not happy with this color. Yeah, I think, yeah, I have a yellow color. Fine. Okay, so this particular formula, third one, that is n is equal to V upon 24. So V is the volume of the given gas. It's not liquid, sorry, volume of the gas. N is the number of moles, and that you have to divide by 24. Now when V is in liters, the volume is in liters, this denominator you have to take as 24. But if your V is in centimeter cubes, then the formula will be like this. Okay, so N will be equal to V, if it is in centimeter cube, okay, then instead of 24 you'll have to take 24,000. So this formula and this formula both are same. Only thing is you have to check whether the V is given in liters or in centimeter cube, right? And the fourth formula is pertaining to the solutions. Okay, then the formula says that N, that is the number of moles, is equal to the volume in liters again, multiplied by the concentration of the solution. Now remember, your concentration of any solution, okay, has to be in mole per liter, either mole per liter or mole per decimeter cube. Okay, as I told you, liter and decimeter cube are one and the same. So the concentration has to be in mole per liter or mole per decimeter cube. So if that is the unit, then the formula will be number of moles N is equal to volume in liters multiplied by the concentration in moles per liter, right? So this four formulas is something that we are going to play around with. And let us get started with the very first numerical. And all these numericals are from your course book itself. Some of them are worked out examples and some of them are exercise problems. Anyways, you need to do a lot of practice and these examples will help you in doing that. Okay. Example number one says that calculate the number of atoms of carbon in A 0.5 moles, B 0.1 moles. Now looking at this question itself, you will come to know that they are asking you to find out the number of atoms. Okay. And so you'll have to do something about this. Okay. Avogadro's number. You'll have to find out the number of atoms. Okay. In 0.5 moles, right? And 0.1 moles of carbon, right? So first one is 1 mole of carbon contains 6.02 into 10 raised to 23 atoms. Now this is the definition of 1 mole. In a mole of any substance, you will have this many particles. Now here we are talking about carbon atoms. So the particles, we will have to tell that these particles are atoms. Okay. So 1 mole of carbon will contain 6.02 into 10 raised to 23 atoms. Now, if that is the case, 0.5 moles will contain how much? So straight away you have to use that unitary method. Okay. So using unitary method, the answer will be 0.5 times 6.02, isn't it? So 0.5 times 6.02 will be how much? So it will be 3.01 into 10 raised to 23 atoms. So this is the answer, right? Now suppose the 0.1 mole of carbon is given. Okay, 0.1 mole of carbon is given. Then what will be the answer? Then here again using the same formula, you'll get 0.1 into 6.02 into 10 raised to 23, which works out to 0.1 can be written as 1 by 10 into 6.02 into 10 raised to 23. So ultimate answer will be 6.02 into 10 raised to 23 atoms. Okay. Here I made some mistake. 0.1 is 1 upon 10. 6.02 into 10 raised to 23, and there's here it should be 1 second, 0.1 moles, right? 1 upon 10 into 6.02 into 10 raised to 23 upon it. It should be 22, I suppose, over here, right? Okay, it should be 22. So let me do that correction for you. Yeah, it has to be 22. Right? 23 upon 10 will be 10 is to 23 upon 10 is to 1 will be 10 is to 22. That's the answer. Now, let us move on to example number 2. Here, he is telling you calculate the mass of A, 2 moles of iron, and B, 0.25 moles of iron. Iron ka AR value is 56. Now, again, you will have to use this formula. N is equal to M in grams upon AR. Okay, this formula you have to use. Right? So according to this formula, N is given to you as 2 moles, right? This we are doing A. So 2 moles, and M is something that you have to find out, calculate the mass, so you have to find out. And AR for this Fe is 56. So you get 2 is equal to M upon 56. So M will be 56 times 2, which comes out to 112 grams. The second one is 0.25 moles of iron. So again, N is equal to the same formula you have to use. Only thing is for N, you'll have to take 0.25 equal to M upon 56 because it is iron. 56 is the AR value of iron. So 56 multiplied by 0.25 should give you the mass in grams, and that works out to 14. So 14 gram is the answer. Next is example number 3. Calculate the number of moles of aluminium present in 108 gram and B 13.5 gram of aluminium element. Fine. Now this is a question where the mass in gram is given to you and they have asked you to find out the number of moles. So again the formula will be same. N is equal to M in grams upon AR. But now you are supposed to find out what the number of moles. Okay. So N is equal to M upon AR, and M is given as 108 grams. So you'll take M as 108 divided by AR. AR for aluminium is 27. So 108 upon 27 works out to 4. So the answer will be 4 mole. Now here remember this 4 MOLE you should not write, you should write just MOL. It's like kilogram you write kg, centimeter you write centimeter. Okay. Same way for mole you have to write MOL. Right. So this is the short form of writing mole. So this is 4 mole. Right. The second one is when the weight, when the mass is 13.5 grams. So same formula, N will be equal to 13.5 divided by 27, which works out to 0.5 mole. So this is the answer. Now let us move to next example. What is the molar mass and the RMM? Okay, B is also RMM of ethanol. Okay, so ethanol C2H5OH, right? This is a molecule, right? So what is the molar mass? Now A is, you have to find out the molar mass. Now what is molar mass? Molar mass is the mass of 1 mole. Okay, in grams, of course. Molar mass is the mass of 1 mole of a substance in grams. So 1 mole of ethanol contains what? 1 mole of ethanol will contain 2 moles of carbon atom, right? And you have total 6 hydrogen over here. So 6 moles of hydrogen atom and you have 1 oxygen atom. So 1 mole of oxygen atom. So this molecule I have split into atoms, right? So 2 moles of carbon, 6 moles of hydrogen and 1 mole of oxygen. Now let us calculate the number of atoms, okay, the particles. So 2 into 1 mole of carbon means you'll have to take 2 into 12, okay, because 12 is what the uh, AR value of carbon, okay, and this hydrogen ka AR value is 1 and oxygen ka AR value is 16. So you'll have to take 2 into 12 plus 16 into 1 plus 1 into 16. This works out to 24 plus 6 plus 16, which when you add up you get 46. So this 46 is nothing but the molar mass of ethanol, okay. So molar mass of ethanol will be 46 gram per mole. Now here you remember this gram per mole, this is the unit of molar mass. What is molar mass? Molar mass is the mass in grams of 1 mole of a substance. That is why the unit is gram per mole. For 1 mole, the mass will be 46 gram for ethanol. Is that understood? Okay, fine. Now, the next one is you are asked to find out the RMM value of ethanol. Now, RMM value of ethanol and the molar mass of ethanol both should be same. Only thing is in RMM you are not going to express the value in gram. Okay, so this 46 you are not going to add gram in front of that. So only you are going to write 46. So relative molar mass of ethanol is just 46. Okay. So for example, suppose H2O, the molecular mass is 18, right? So 1 mole of this water contains 18 gram. That is the meaning of it. This is known as the molar mass of water. Molar mass is 18 gram. But RMM of water will be just 18. You don't have to write gram over there. So RMM is nothing but the molar mass expressed not in grams. That way you can take it. Or you can say this way that the molar mass is the RMM value expressed in grams. Okay, so that if you want, I'll write here. Yeah, it's written over here. RMM is the molecular mass without the unit gram, and molar mass is the molecular mass in gram per mole. Okay, fine. So that was this question. Now there's something I've written over here. Molecular mass not expressed in grams is the same as RMM. Okay, so this is very clear now to you. RMM is something which is only a number. You don't have to write gram in front of that. And if you want to write molecular mass, you will have to write the RMM value and you will have to add a G in front of that. So it is RMM expressed in grams. Okay. So molar mass is molecular mass expressed in gram and its unit is, now this is a very important statement. Molar mass is molecular mass expressed in grams, okay, and its unit is gram per mole. Is that clear? This molecular mass is nothing but mr. You write this relative molecular mass. Relative molecular mass. Okay. Now number of moles n is equal to m in grams of a of a given molecule upon mr. Now this formula, you know, this is formula number 2, right? This formula also we are going to use now. So let us proceed with the next example. What is the molar mass and the RMM of nitrogen gas? What is the molar mass and the RMM of nitrogen gas? So nitrogen N2 is a diatomic, so it consists of two nitrogen atoms. Molecules, molar mass of nitrogen will be Ar of nitrogen, and because there are two atoms making one nitrogen molecule, you will write 14 plus 14, so 28. So this 28 is your Mr of nitrogen. Okay. See, I have not put a G over here. Now he has asked you what is the molar mass. So molar mass is nothing but you have to put G in front of that. So molar mass of nitrogen will be 28 G per molecule. So this is your molar mass of nitrogen, and this is your RMF of nitrogen. The difference is in RMM you don't put G, and in molar mass you put G per mole. Okay, that's the only difference. So RMM of nitrogen is 28, and that's it. Okay, RMM is just 28. RMM of nitrogen will be just 28. You are not supposed to put G in front of that. Okay. Now going to the next example. Calculate the mass of 3 moles and B 0.2 moles of carbon dioxide. Now carbon dioxide is CO2. Carbon ka AR value is 12 and oxygen ka AR value is 16. Fine. So what will be the MR value of carbon dioxide? So MR of carbon dioxide will be AR of carbon plus 2 times AR of oxygen, isn't it? Now AR of carbon will be 1 carbon, no? So AR of 1 carbon. So AR of 1 carbon will be 1 into 12, and 2 times AR of oxygen is 16. So this will be the value. So 12 into 1 is 12 plus 16 is 32. This works out to 44. So 44 is the MR of carbon dioxide, right? Separately I have worked out for you. Now this formula you will have to use here. N is equal to M in grams upon MR for carbon dioxide. Okay, so 3 moles is given to you. So N you take as 3 equal to M in gram upon 44. Yeah, MR value for carbon dioxide just now I calculated for you. It is 34, right? So M will be how much? M will be equal to 3 times 34. So 3 times 34 is 132. So the answer is 132 gram. Second is you have to find the mass of carbon dioxide, which is 1 mole. Okay, so 1 mole of carbon dioxide, no, 0.2 moles. Now this you can do this way. 1 mole of carbon dioxide consists of 2 moles of oxygen and 1 mole of carbon. Okay, this he has worked out, nothing else. So 2 into 16 plus 1 into 12, that is 44, right? So 1 mole of carbon dioxide is 44. So 3 moles of carbon dioxide will be, this is another alternative way of doing it. Okay. So here again you are getting 132 grams, the same question. Now B part is 0.2 moles is how many grams? So 0.2 equal to M upon MR. So 0.2 equal to M upon 44. So M will be 0.2 into 44. That works out to 8.8 gram. Okay. Now let us move on to the next one. Mass of X mole. Now this is the concept that you should understand. Mass of given X mole of compound is equal to uh, N number of moles multiplied by MR, that is the molar mass. Okay. So this is just the rearrangement of the formula. This formula N is equal to M in grams upon MR. Okay. This is just a rearrangement. So N into MR will be M in grams. That is what I have written here. Molar mass you can get from the molar formula. Okay. Molecular formula. Molar mass also you can get from the molecular formula. Right. Chalo, let us go for this next example. Calculate the number of moles of magnesium oxide, MgO. Formula you should know properly, okay? If suppose in the exam they don't give you the formula, they just tell you calculate the number of moles of magnesium oxide, then it's up to you. Like if you know the formula, it is good. Now certain students, they may wrongly write the formula for magnesium oxide as MgO2, something like that, okay, by mistake. So if they write MgO2, then the MR value will go wrong. Okay. So the right formula for magnesium oxide is MgO. Now in 80 grams and in 10 gram of the compound. So MgO, suppose 80 gram is given to you, then what is the number of moles? And when 10 gram is given to you, MgO, what is the number of moles? That is what you have to find out. So first let us find out the MR of MgO. So MR of MgO will be equal to, now MgO में you have one magnesium atom and one oxygen atom. So magnesium का AR value is 24 and oxygen का AR value is 16. So 24 for 16 is 40. So 40 is the MR value of MgO. Now using this formula, N is equal to M upon MR. M is given to you as 80 gram for A. 80 gram upon MR is 40. So 80 upon 40 is 2. So 2 mole is the answer for this A. Second one, B1 is 10 gram. So 10 gram upon 40 works out to 1 by 4, that is 0.25. So 0.25 mole is the answer for this B part. Okay. Next is calculate the number of moles of ammonia gas in a volume of 72 decimeter cube of gas at room temperature and pressure. RTP means room temperature and pressure. Okay. Now, this particular formula, this particular problem, numerical, is based on ammonia gas. And I told you when you deal with gases, you have to use this formula. N is equal to V in liters divided by 24. Okay. So this is the formula that we are going to use now. So N is equal to V in liters upon 24. And the volume in liters is already given to you. It is 72 decimeter cube. And I told you decimeter cube and liter is one and the same. So volume will be 72 divided by 24 is already there in the formula. 72 divided by 24 works out to 3. So it is 3 moles. Next is calculate the volume of carbon dioxide gas occupied by 5 moles and 0.5 moles of the gas at NTP. Now NTP, RTP are all one and the same. NTP is normal temperature and pressure. Okay. Not the same, but RTP is room temperature pressure, NTP is normal temperature pressure. Okay. So when the gas is at normal temperature and pressure, what is the value of, calculate the volume of carbon dioxide gas when it is 5 moles, okay? So again the same formula, N is equal to V in liters upon 24. Now in this case, the moles is given to you, N is given to you. So take that as 5 equal to V upon 24. So V will be equal to 24 into 5. When you multiply this 24 into 5, you get 120. And the unit will be liters, of course, because this V is in liters. And for 0.5 moles, 0.5 equal to V upon 24. So V will be equal to 0.5 into 24. That works out to 12. So answer is 12 liters. Okay. The next one is calculate the concentration in mole per decimeter cube of a solution of NaOH which was made by dissolving 10 gram of solid NaOH in water and making up to 250 centimeter cube. And your given AR values for hydrogen is 1, oxygen is 16, sodium is 23. Here again, this question says that calculate the concentration. So you have to calculate the concentration. You have to find the concentration. And this is a numerical which is talking about a solution. So you will have to use the formula pertaining to the solution, and this is that formula. N is equal to, that is number of moles, is equal to volume of that solution, that is V in liters, multiplied by concentration, right? Now they have asked you to calculate the concentration. So C is something that you are supposed to find out. So C will be equal to N upon VL, isn't it? C will be equal to N upon VL. So we have to rearrange this formula. Now N is the number of moles, which is it given to you? No, it's not given to you. So you'll have to find out first the number of moles. Okay, because 10 gram, the mass is given to you. For NaOH, the mass is given to you. So use this formula and find out the number of moles first. So N is equal to M upon MR. M you will have to take 10 gram because 10 gram of NaOH he has told you to take, divided by MR. MR of NaOH will be 23 plus 17, 40. So 10 upon 40 works out to 0.25 mole. So this 0.25 mole is the value of N. Okay. Now in this formula, C equal to N upon V, you can very nicely take N as 0.25 divided by volume. Now volume is given as 250 centimeter cube. Okay. But you are supposed to take the volume in liters. So 250 centimeter cube, you will have to divide by 1000 to get the answer in liters. And if you do that, you will get 0.25. So this 0.25 is the volume in liters, okay, which should be in liters. Okay. So this works out to 1, and this is mole, right? So the unit will be mole per liter or mole per decimeter cube. So the answer is 1 mole per decimeter cube, right? This is the concentration of this particular solution. Okay. Now, today's session, I think I'm going to end here itself, okay, because time doesn't permit me to go ahead. And from here, I'll be doing this numericals in the next video. So today's video, I would like to end here itself. And if you happen to like my video, please subscribe my channel. And that's all for today. Thank you very much. Bye.